Good morning, all. Good afternoon, all participants. I think we can start our today's session. So, first, I would like to welcome you all for today's Gyan course, which is entitled Generative AI Foundation, Gyan, VAE, and Real World Image Generation Technique. And for today's session today's is consist of two sessions. In the first sessions, we there is a discussion related to prompt engineering to AI agent, and its related hands-on sessions will be in the session 2. And for that, I would like to invite our today's speaker, Dr. Darbaneshwar. He is currently an employee of Walmart Global Technology Private Limited, Chennai, and his research areas are generative AI, LLM, NLP, machine learning, deep learning, and computer vision, robotics, social mechanics. Regarding his education qualification, he did his dual degree MTech along with the PhD in the Department of Engineering Design in IIT Madras, and he completed his BE Mechanical Engineering in College of Engineering, Ginti, Chennai. He received a lot of awards, namely IDC Excellent Award 2024 from Walmart Global Technology Private Limited, Chennai. And second award is Graham Bell Award 2022 under the category Innovation in Retail from Ministry of Industrial Development, India. And another award called Dewey Decimal Award 2022 from Entropic Technology Private Limited, Chennai, and so on. Regarding his publication, he published more than 10 research papers in the reputed journal with the impact factor which is varies from 1.8 to 3.3, namely the Springer Gracelyn Society of Mechanical Science and Engineering. He submitted the patent which entitled System and Methods Using Fiducial Makers, CAD Model of Parts, Commodity Camera, and Autonomous Entity for Part Inspection, Metrology, and 3D Reconstruction. And before Walmart, he worked in Whaltech, Chennai, Entropic Technology Private Limited, Chennai, then Mahindra and Mahindra India, and he be a speaker and also conducted FDP. He be a speaker for the workshop entitled AI and ML in NIT Trichy and BITS Bilani, and he delivered a lecture in various sessions related to the deep learning, and the lectures Deep Learning for Computer Vision in Biotech University, Chennai, Birds for NLP in Presidential University, Bangalore, NLP, the topic NLP in Silver Jubilee Lecture Series in NIT Trichy, and another workshops entitled ChatGPT, Theory and Practice in Biotech University, Chennai, and another is Vision Transformer in Biotech University, Chennai, and he conducted FTP on Transformer and GPT in Sarnath College of Engineering, Trichy. So I welcome you, sir, for the today's session.
Thank you, Vishnupriya. Hope I'm audible.
Yeah, yes, sir. How about the participants? Can you raise your hand or sir? Hopefully they might be, sir.
Okay. Then can we get started? Thank you for your kind introduction, Vishnu.
Yes, sir. They show the thumbs up, so you can continue, sir.
Sure. Let me share my screen.
Hello.
I think hopefully today's session is very interesting. It's related to prompt engineering, and he is from industry. So make this session in the. You, so you can continue, sir. Sir, it's audible. Hello.
Ma'am, can you hear
Yeah.
me?
Yes, and now it's.
Yeah, I'm sharing my screen. Can you please acknowledge whether my screen is visible?
Yes, you can share, sir.
Yeah.
Yes, sir, it's visible. Sir, you can go ahead, sir.
Ma'am, am I audible?
Yeah, audible, sir.
After sharing my screen, whether you can hear my voice because I was speaking.
No, no, sir. No, it's not audible.
Oh, yeah. Sorry. I got it. Now I think you can see.
Sir, still it's not audible, sir.
Just a second.
Yes, sir. Sir, still it not audible, sir.
With the session. Um, so this session is going to be about the AI agents. Like, just a second. Sorry for the technical glitches. Let's start with the session. So this session is going to be about the AI agents, like how as an industry we are.
Hello. Sir, you can start, sir.
Yeah, can you hear me, Norman?
Yeah, yeah, sir.
Okay, great. Yeah. So this session is going to be uh, how we are using AI agents from the industry standpoint. That is, starting from the prompt engineering to the RAG, what technologies are being currently used, and how we can uh, do research from academic standpoint as well as how we can use it in the industry standpoint. Okay. So I will give a very brief overview about starting from AI, then slowly getting into Gen AI, and then ChatGPT, and then finally RAG, and also AI. So before getting into the session, like, what do you guys think about AI? Like, I just want this session to be a bit interactive. So let's start from your perspective. What do you think about AI? Any thoughts? So AI is nothing but what we can do, and we are asking a mission to. So that to put it in a very simple words, it is kind of imparting our human intelligence to machines and tools so that they can assist us in our well-being. And AI, as you can see in the slide, it is in various domains, like it is in NLP, it is in computer vision, it is in robotics, and it is in expert systems. So it is not just restricted to robots. So if you take the era of 2000 to 2010, roughly, AI is kind of more of robotics. So like uh, uh, how robots are assisting in the manufacturing and automation tasks, and how robots are useful in uh, the most popular mobile robotics. All those, like, mostly AI was completely related to robotics. And then the computer vision models come in. We have cameras in our smartphones and we have the face detection. So if you take like 2010 to 2000, I would say like till 2017 at least, mostly it was camera oriented. Like we have selfies, we have face detection, we have smile detection, we have emotion detection. All those was getting so popular in this era. And right now it is NLP. We have GPTs, we have OpenAI, we have Gemini, we have, uh, I mean, Llama, all those models now, NLPs are getting so popular. So what I'm trying to say is AI is nothing which is out of the box started. Like we are adapting AI everywhere right now, but it is not that AI has started now. It has been from 2000. Okay. And what is AI intended for is autonomous adaptability and ability to assist and process information. Okay, so any AI technology, it is for autonomous capabilities and for adapting to several tasks. Okay, now how AI is evolved? If there is a question like what, from where it has started, it has started from, I would say, like more precisely, I would say 1997. Okay. And from there on, right now we have in 2016, we had AlphaGo, which is a AI software which is used to for simulating chess, and even it was won a global championship. And slowly AI was penetrating into each and every task in our physical world. Right now, that's how AI is getting focused. Now, there is a very, very common myth, or I mean, myth or something like, what is the difference between AI, ML, and DL? To put it in a very simplistic words, AI is a system. It is an umbrella of machines that helps in autonomous things, or that has autonomous capabilities. And ML and DL are the tools which are used to uh, build AI systems. Okay, so let me take like the machine learning algorithm. Machine learning algorithm, it's kind of learning patterns from the data. Say, let's say we have the famous housing price prediction. We say the size of uh, the size of the house determines the price. Bigger the house, huge is the price. So these are the rules, and these are the data points follow these rules. And the ML algorithm tries to learn these patterns or implicit rules or explicit rules and try to come up with some mathematical model. So given that model, you feed the parameters, you get out. So that is a machine learning problem. And when you get into a deep learning problem, it is one layer or it's a bit more advanced to ML where you try to unveil or you try to learn complex features. So in machine learning, the problem or the features are so simple or kind of not so deep enough to so that you can understand with naive logistic regression or linear regression algorithms. Whereas if you come into deep learning, it is having a bit complex features like where you want to learn one layer inside, and these complex features will come in images. You can see an image, like if you take an image of shelf which has lot of items, you will find lot many complex features inside. Let's say you take a rack, a supermarket shelf, where you will have lot of items which is stuffed in or which is piled up in that rack, and you want to count the number of items in each row of the shelf or each category of object in the shelf, or you want to deduce number of categories in the entire shelf. So these are some kind of complex problems because each object will have its own feature, and you have to deduce what is that object from the image given, like one image or even 10 images or 100 images. You want to identify a bottle or you want to identify a mouse or whatever it is, like from the image you are identifying an object, and that's typically we call those problems as object detection problem, which comes under computer vision, and all those are deep learning problems. So compared to ML and DL, the main difference is the complexity of the underlying feature. And deep learning is primarily for images because, of course, images has lot of complex ones. Okay. So the A is the bigger umbrella, and TL, ML, all those will come inside those umbrellas. Okay. So the region of problems that you solve, that will determine which kind of algorithm you are going to use. And how this entire AI system is evolved. Is it suddenly after the evolution of ChatGPT or after giving the ChatGPT to the entire, to the entire community, entire public AI evolved? No. So it has started from 1950s. So if you see like the basic computers, which is kind of helping us in calculations, that is where the basic expert systems evolved. So that is at the era of 1950 to 1980. And from 1980, this neural networks, all those papers were coming in. So how it was, it's, there are research papers where they try to simulate how a brain thinks. So there is a very famous example. Like I say something to someone sitting near me, and someone who is sitting far from me will get some information, but he may or may not get what I say. So that is how the neurons are connected. So this way the brain works, the neural networks try to mimic the way the brain works, and the researchers have come up with those algorithms long back in the era of 2000 itself. But the way major problem is the hardware. We don't have the hardware or the compute system to train those algorithms at that period. I'm saying in the period of 1980 to 2000 or 2005, something in that range. We were not able to train those algorithms, or we don't have that much data. And why we don't have that much data? Because of course, internet was evolving at that period. Very few houses had internet. Broadband wasn't so popular. We don't have Wi-Fi, smartphones. All those things were not so popular at the age of 1980 to 2000s. And that is the biggest block, or the biggest obstacle for the evolution of AI. And slowly things were changing. Like we had our hardware, we have internet, we have the data, all those were coming in. And then we started at 2010 MLDL algorithms. 2014 to 15, computer vision was so popular. Like there are a lot of jobs in computer vision if you go in the period of 2014 to 2019, 18, I would say. These 4 years, computer vision was a so popular domain, like everyone was getting into the job. And now, after 2019, with the advent of ChatGPT, things changed. And that's where generative AI coming into picture, where they totally replace the computer vision. They can say, like, give me image or text, whatever you want, I can give you what you want. That's how Gen AI was evolved. So you can see the evolution starting from 1950 to till now. It is not a one day change, or it's not, I would say, like 2 year or 3 years change. It was a evolution starting from 1950 till now, and it will still continue. People are doing research. Still, we are trying to find something, and things are evolving. Maybe after another decade, I would say in 2035, things will much more evolve. Started from the basics. That is what I'm trying to say. Any questions? Now, this in this generative AI, LLM is the core model. Like generative AI has different avenues. So you can take an image, it will give you an image. You give a text, and if you want to generate text, it will happen. So this text to text generation, that's what is happening with LLMs. Okay, LLM, uh, those are mainly language models. Okay, which will take the text and it will give you the text. Okay, and how it happens is basically the core architecture is the transformers. So this session I will not delve into the theory of transformers. Rather, I will give you a brief overview of how things are working over there. Okay, so uh, how it happens is, let's say I say I live in, and basically you guys can come up with some text saying like possibly Chennai or Tamil Nadu. So all these, the next probable word for that sentence, how we humans predict, the similar way LLMs works. Okay. So we ask the question like what is AI to Gemini or OpenAI or GPT, anything we ask a question. It tries to answer what will be the next probable word. In LLM, we say it as tokens. So token is nothing but 3/4 of a word. Okay. So what is the next probable word? That's how LLMs think. Okay. And what are the capabilities of LLM is it has a very good contextual understanding. It tries to generate text. And with this limitation, I mean, with this strength, it is widely used in chatbots. So if you take any company right now, even you can go forget about the sector the company is, like it's a finance or healthcare or technology. It's not about the domain they work, but everyone they are trying to use OpenAI or they are trying to use LLMs. The idea is how we can leverage this technology so that we can enhance the productivity of the industry people, or we can enhance the productivity of the software. So that's how building chatbots is something uh, very naive, and that's what is being done predominantly in most of the industries. And integrally, they use OpenAI or Gemini or any LLM, maybe their in-house LLM as well, and they develop a chatbot. Is that clear? Now, what is the problem here is they, there is a very good tendency of hallucination. This LLMs, they hallucinate the facts, and they require a lot of computational resources or potential for, because if you want to train a LLM, you require a lot of computational resources, and that's why OpenAI is so popular. So they are trying to uh, generate. I mean, they are trying to use LLM to for computational purpose. They are using the LLMs of OpenAI, where they just expose it as a API. Okay. And another problem is the bias. So LLMs may be biased if you didn't do prompt engineering properly. So what is prompt engineering? I have mentioned like LLM may give inaccurate or biased outputs if your prompt is not correct. See, prompt is nothing but the way we question the LLM. To put it in a very simple word, the way we question the LLM, how clear and precise our question is, and that much accurate our answer will be. Okay. So let's take this is a very typical format that we use. We say a question, we say example, like what given a question, how you should answer, and we say a format. Okay, I want the response in a JSON with this field, with this output format, all those things. So all these are given in the prompt, and this is how you engineer a prompt. Okay, so there are few things here like setting the context and then chaining of instructions, guiding with examples. So setting the context in the sense. Sorry, is there any question?
Yes, sir.
Yeah, 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 Manisha. You have any question?
Hello.
Hello.
Yes, sir.
I mean, is there any question for you?
Sir, here.
Sorry.
Can you repeat it?
Which one? Which one, Manisha? This slide, prompt engineering.
Sir, yes, I think it's unmuted something now. You can go ahead, sir.
Okay. So what I was saying is, in the prompt engineering, we basically set the context of what you want to do. Let's say we are building a, customer service chatbot. So what is the basic intent of the chatbot? We have to say like response in a polite manner and don't reveal any sensitive information, and as well as try to make the resolution of the customer complaints, right? I mean, try in the sense you have to. So we have to set the context of the chatbot. That is called context setting. That is the behavior of the chatbot. And then explicit chaining of instruction is you have to give a very detailed step-by-step instructions, like what you need to do or what you expect the chatbot to do. And then guide with examples, like you say, hey, I have a resume in this format. This is the JSON format of my resume, and I want to generate insights out of my resume. And my insight should be in this format. If I explain all these instructions, it will be much more better if I give with an example. Like this is the resume, and this is how the insight is, and you can see how I extracted the insight. In a similar way, you have to do this. This is called as zero shot prompting. Sorry, few shot prompting. In zero shot prompting, you won't give explicit examples, which is nothing but the short. Whereas in few shot prompting, you explain with an examples, with some examples, one or two maybe. Okay. Now, after you set the context, you chain the instructions, you guide with examples. That is how you finally come up with the industry design prompt or a proper engineered prompt. So a prompt is nothing but a simple name thing that we usually do. It is a pool of instructions which should be designed in a very appropriate. Is that clear? Okay. Now, and these are the best practices in the prompt. So what you need to do is you have to be very clear and specific. You have to set the persona of the prompt. By persona, what I mean is, let's say you are developing a chatbot for talent guidance or talent acquisition or for recruitment. You have to set, hey, you are going to be a recruiter for a very big MNC, and you have to scrutinize the applications and come up with the appropriate candidates for the further processing. So this is how you have to set the persona of that chatbot. Okay. You have to remove the ambiguity. You have to say what not to do, what to do. Because if you didn't say what not to do, it may result in giving out some sensitive information. Okay, you have to structure the prompts and then you have to specify the output format. So this is how the entire prompt engineering best practices that must be followed, and we as an industry we are following it with a very strategic perspective, so that the outputs are as expected as it. I hope it's clear. And prompt engineering, like I mentioned, these are the types of prompt engineering. Like you have a zero shot prompting, you have one shot prompting, and you have two shot prompting. It is basically how many examples you give and how detailed your examples. Okay. There is other type of prompts called chain of thought prompting and also a React based prompts. So here how it works is chain of thought prompting is nothing but how we will typically solve a mathematical problem. Let's say if you ask a sixth standard child or some mathematical question, you break it into parts, right? Like let's say a car has four wheels. So if we have three cars, how many wheels? So we will say like four cars is for one wheel. I mean, four wheels is for one car, and then three cars in the sense four into three total. So in a way, we think in a more systematic manner. Although we do this in milliseconds, but that's how our brain is working. In a similar way, we give LLMs the instructions so that it will be able to solve the mathematical questions. See, the fundamental thing in LLMs is that it is good for reasoning tasks. Okay, it is very good for reasoning tasks, but it is not good for the mathematical questions. Okay, so there are several benchmarks, there are several research works going on to improve the mathematical reasoning, mathematical question answering skills of LLMs. That is happening, still happening, and it will be going on. But the first thing is in that from a prompt engineering perspective, chain of thought problem. Okay, and there is the second thing is the self consistence and react. So react is nothing but so how we work. We think something and we come up with some solution. We reason out it and we act it. By reasoning out what you do, whether the solution is correct, can we proceed? And if it is everything is okay, we act on that. So think, reason out, and act. That's how React framework works. Okay. So we basically say in the prompt, hey, you have to given the question. First, you think like this. Then after thinking, let's say you come up with few steps, and then you reason out that steps. And if you find everything is okay, finally execute that steps. So that's how this React-based prompts works. So although I may explain something like you have to come up with some paragraph of instructions, it's not like that. It's basically each prompt is an instruction. Okay, so you can have a chain of prompts for thinking, and then finally reason out, and then finally act. And you chain these prompts, and you execute these prompts via LLMs, and you get the output. That's how, and here you have the tools, all those things will be coming. We will get into those in the agents perspective. But what I'm trying to say is these are not just giving a set of instructions to LLM and executing. Each one has a specific pattern, and you must follow that pattern. Then only you will get accurate output. See, the thing is, right now AI is democratized. What I mean is, you have in your phone, you have Meta AI in your WhatsApp, you have Gemini in your Android app in your phone. So anyone is using AI, even though they know or know it, it's not doesn't matter. It's kind of camera. You need not learn what is camera to use it. It's kind of a tool right now. So now what makes it different from an industry professional or from an academic professional is how we are diligently using that tool. Okay, so this prompt engineering might sound simple for a naive user, But for an expert user who is using AI, who is building serious AI applications, secure AI applications for high grade industry systems, they definitely must or know all these aspects. See, me, even myself, like when I was starting to use from 2019 or 20, when this ChatGPT come in, I was thinking like, hey, it's just a couple of instructions we are giving. But slowly, if you these softwares, when it enter into a high grade, secure databases, when they take data points from there and they execute, there you find lot of things. I mean, lot of challenges, I would say. What are the challenges? The challenges are nothing but it may steal your data. It may steal in the sense like it may take your data and it may give results, and those data might be sensitive. You need not reveal that data, or there is a possibility like you may get inaccurate outputs and you don't know the reason. So prompt engineering, even though you go for RAG or highly advanced AI model, which is super accurate, but there will be some instances you will face inaccuracies if your prompt is so naive, so simple. So these strategies are keep on evolving. Like you have tree of thought prompting, and the frameworks of prompt engineering is so high. Like it is evolving day by day, I would say. But having a good hold of your problem and a good hold of how to engineer the prompts definitely will help you to solve and use AI more diligently. Now we will get into the AI agents. So far I have covered what is AI, the LLMs, and then the prompt engineering. So from a very user standpoint, usability standpoint. Now we are getting into AI agents, which is the hot topic right now. So if anywhere you go, you will find agentic AI agents, how agents can be used, how MCPs are used in agents. So this agent is the next level of LLMs. So just to put it in very simple words, an agent is nothing but you have a LLM as a code and you dedicate your agent to do some task with LLM as a code. Okay, so let's get into the understanding from the flowchart that I put here. So you have a AI agent. Okay, so what it does is you have the prompt, you have the task, you ask it to execute. Okay, and you give all tools which is required to solve that problem. So it's not like I have you just use a LLM and solve. Of course, that is also an agent, but an agent is capable of using n tools which is at its disposal along with the LLM. So LLM will decide which tool to use. Hey, what is the weather now? Let's say I ask my agent this question, what is the weather now? The LLM will say, okay, let's go to the weather API, let's hit the API, let's get the current temperature location, and then we give the result. Or I may ask, like, what is the temperature in London? So obviously it will say, okay, temperature, London, the location is London, let's hit the API with weather API with the location, get the temperature, get back to the user. So this agent is nothing but a dedicated person which has been assigned the task to generate results. Is that clear? So here, the task can be anything. Okay, and the resources, the sources that you want to assist the agent to solve it, it can also be anything. By anything, what I mean is it can be any data document, it can be a code base, or it can be SQL data. So you put all these in a proper data generation pipeline, and then you give the output. That's how this agents work. Okay, and again I would say, like, why agents now? Why is there no agent before? We had agents. If you remember, like the self-driving car, where it automatically detects the obstacle and it automatically detects the road and it deduces the driving path and it goes automatically. All those any agent or any device which has autonomous capability is called as agent. Okay, a robot is an agent. So a robot which is assigned for cleaning the floor, that's the agent. So it has been. I hope some might be aware of SLAM, simultaneous location and mapping. So robot, when you just put it in your room, it creates a map of your room. It localizes itself on the map, and then it automatically navigates and cleans the room. So that is called a SLAM, simultaneous localization and mapping. It localizes itself, it creates a map, and then it wanders around and cleans it. As simple as that. So that is called a SLAM. And that SLAM robotic system, that those are agents actually. And right now we have AI agents where rather than going for these kind of hardware based tasks, we have software based tasks. By software based task is nothing but, let's say I ask the question like how many students are there in NIT Trichy. So obviously what it needs to do, we need to access the NIT Trichy database, how many departments are there, and each department how many students are there, and then it finally comes up with some number. So this, as a human, we get into the SQL database, we put the query, we get the number, we add it up, we give, let's say a agent does, you give access to all the databases, and you ask the question how many students are there in the NIT Trichy, and it automatically does all this. That's how agents do. Agents are built for autonomous tasks. Now, very fundamentally, the AI agents, right? It will have a perception, it will have a knowledge base, it will have a reasoning and decision making task, it will have a learning mechanism, and finally it executes. So let's think from a very simple robot perspective. So you take a robot. What is perception does? Perception is nothing but it kind of understands the environment. So that's what I said. There is a simultaneous localization and mapping technology where it tries to localize itself in the environment and it tries to map the environment. That's called perception. And then the knowledge base and memory. It stores the perceived environment in the memory. And then we have the brain. The brain is nothing but the storage medium where it stores the data. And then we have the reasoning engine, which is nothing but our LLM. So in the case of robot, it is nothing but the ROS. So we have a robot operating system where it has all the algorithms, all those which is try to help it to navigate, it try to detect the environment, map the environment, all those things are done in that engine. And for software-based tasks like the agents that we have right now, we have LLM. And finally, all those comes under execution. So AI agents, again, I would say, as I started before in the very first slide, I was saying like artificial intelligence was starting from 2000 and right now it is in 2025 at this age. Similar way, AI agents also, it has started long before. SLAM is a very old technique which has started, I would say, in 1999 or 2000. I think somewhere at that period it has been started. And right now it is getting so popular. Like even software-based tasks are getting automated with AI agents. Okay, AI agents again it is defined by the behavior. Okay, so there is simple reflex agents like, for example, the thermostat where we measure the temperature, or also we have this model-based agents and also goal-based agents. All these agents are defined by what kind of behavior or what kind of task they are assigned. Okay. And if you get into the other type, which is the collaboration and learning. So here, if you take the multi-agent system, right? In multi-agent systems, you have multiple agents which will be coordinating and which will be interacting and it will be helping to solve the problem. And this is called as agentic rack. So I will take another session on rack. In that, I will discuss about the agentic rack, but it is a multi-agent system. So by multi-agent, what I mean is each agent has a LLM inside it. Okay. and each agent is assigned with a dedicated task. And what is the task is, let's say I'm asking a question. The first thing I need to do is, the company is a very reputed MNC, and you can't ask some personal information or PAI related information. So there will be an agent. It will kind of scrutinize. Hey, are you asking some PAI sensitive information? No, then we won't answer. Okay, if that agent say this is not a PAI sensitive information, then there is another agent which will try to answer your question. So there is a coordinated interactive framework involved where each agent is taking its task as its own. They own the task basically. So that's how this multi-agent systems are there. Okay. And then we have learning agents like which it's kind of the game-based learning where you slowly train your agent, which the background may not be LLM. It will be a reinforcement learning framework, a reinforcement learning algorithm, which kind of uses agentic framework to improvise itself. And of course, the embodied agents, which is nothing but physical robots. And we have the software agents, the one I was discussing so far, the Google Assistant, Alexa. All those are agents which is assisting in day-to-day tasks, which helps us in looking better, all those things. And what are the current trends in AI agents? So far, whatever I have discussed, I have given a very broader framework of what are agents and how software-based AI agents get in. And right now, the AI agent that we are working, like I am as an industrial professional, uh, what we work in Walmart or any other concern, how they typically work is they have this kind of flow chart, which you can see here. Okay. So in this flow chart, you can see, so in this flow chart, you can see there are tools and there is a memory and there's a planning. Okay. So what happens here is these tools can be a search API, okay, maybe a weather API or maybe a database, all the necessary equipments. Like let's say I am uh, there's a mechanic or electrician, he has a set of tools. Without those tools, he can't work. In a similar way, agents require these tools, and memory is nothing but history. So by history, what I mean is it remembers what I was asking, and it also has a memory of that. And finally, it plans. Okay, this user, he was asking these, and these are the tools we have. This current question is this one, and it plans, it executes, and gets the answer. Okay, so as a industry people, when we are asked to design an agent, we come up with, okay, what kind of tools we need to use, and what is the chat memory that is being so far. Okay, let's say I want to uh, uh, store 10 or 1 week of chat history to answer the question, or maybe 1 day or even 2 days of chat history. Like the memory along which the thread needs to be answered. And finally, the planning is nothing but how I orchestrate this agent, like using the tools, memory, and getting the best answer. So is it clear till now? Any questions? Any questions from participants? So far we have covered about prompt engineering, types of prompt engineering, and then the AI agents and the component, what is that, Llama models, all those, and Hugging Face, where they also provide APIs for accessing LLMs. But all these are the way to access LLMs. Okay, but there is a fundamental another thing is that how we can use this LLMs for doing our task. I mean, the orchestration of the LLM oriented task, how we can orchestrate this. And that's where we have LangGraph. So before there was LangChain actually. LangChain is specifically, we have this prompt, it uses the prompt folder template and you import your text and you use it. So that is kind of a uh, how I would say like a lang chain based frameworks. But here lang graph is basically for agents. Agents in the sense that which require some cyclic process. Okay. So an agent can be a single agent, multi-agent, hierarchical, sequential kind of, and all these control flows we can easily orchestrate with lang graph. You need not say like, hey, first you do this task, then go to this node or go to this task. Like you need not orchestrate that workflow. You give the nodes, you design it, and LangGraph will take care of. So in LangGraph agent-based approaches, we have this concept of nodes and edges. It's a something fundamental concept that you guys might have seen in the graph networks or graph analysis. So it's nothing but how we connect things. So we have nodes, which are the functions or the individual tasks. And edges is nothing but the connection between nodes. Simple. Okay. So as you can see here, nodes will have LLM call, tool, custom logic. So node is nothing but an independent entity. Okay. And edges, it connects the nodes and you can flow from one node to another sequential. And there is of course conditional edges which will say like, hey, if you satisfy this condition, you go to this node. Otherwise, don't come. So it's something like conditional edges, normal edges, and you have nodes. That's how things are connected. Okay. Any doubts so far?
Hello.
Yeah.
Yes, sir. Am I audible?
Yeah, you're audible.
Yeah. So I had asked a question in chat actually. When we are using agentic AI or AI agents, why all of a sudden too much popularity happen for the AI agents? That is the first question. The second question is that when we are doing the AI agents, we are giving agent access to all kind of our database and many of our documentations, etc., so that he can work. So how we can ensure the security of our databases or secure our environment while working on AI agents?
Okay. Interesting question. So the first question, first thing to answer, right? Why agents are so popular? Agents are so popular, of course, because of their autonomous capability. That's why I have mentioned in the very first slide, agents are nothing but it is built for autonomous tasks. So if you have any manual task, the idea of agents is that it completely does it on its own and it finally gives you the output. It's not like you have a chat GPT, you go, you ask a question, you get the answer. It's not like that. It's like your smartphone. It's a dedicated agent. Okay. Now coming to the second question of how secure applications can be built in AI. That is a very ongoing research topic. And of course, there are lot of possibilities of data leakages because hey, you're using an OpenAI API or you're using a Gemini API, and we as a institute or we as a company, we have our own database which this OpenAI or Gemini doesn't have access. Now the question is we are connecting our database to a third-party APIs. There is a data flow is happening. Now the obvious question is whether data leakage is happening or not. And there are certain regulations, I think it's GDPR regulations, which is intact to OpenAI or any AI company, that is they must follow so that they are not supposed to extract or use sensitive information unless otherwise which is explicitly given by the company. And second thing, this is as part of regulation act, these things are there. But we as a concern, we as a software developer, what we need to do is we have a control of what kind of data is flowing into the LLM. Okay, so it's not like anything and everything can be sent to the API to get the answer. So we have the database, we have a jailbreaking mechanism. So to answer your question, If you are sending a prompt with the data from the database or secure information, there is something called a jailbreaking mechanism, which must be incorporated to check for any sensitive info getting out. And this jailbreaking mechanism is custom defined, which means like depending on your problem, you define your secure things which needs to get in and get out. And it must pass in so that you can pass the data to the opening. Okay, so this data engineering pipeline, the data engineering workflow for getting into the prompt and finally getting into the LLM is totally in our control. And like I have mentioned before, since we as a company, we design chatbots for public as well, I mean, for common user usage, we ensure that any PII related information is not asked by the user. Even if it is asked, we block it. And also we have this offensive information or offensive questions being asked. All those we don't permit in our database. Like we won't store that data. It will never enter. We stop it at the very first layer itself. So these are some kind of security layers or privacy layers that we built, which will stop from getting into the system. And even we use LLM over there also. So we ask a question, user asks a question, we ask the LLM or we have the GPT, which will deduce whether it is a PIA related info question or not. Based on that, we stop it over there. So in this kind of filtration plus secure layer building process, we try to avoid these kind of data infiltrations. Is it answering your question or any doubts?
Yes, sir. Thank you. Only thing is that this layer of security is the same while we are doing the prompt engineering from our side, and when we are building the agent will also find the security and it will not go beyond the security layer defined for the agent, because I think you said that if behind the agent it's not necessary that always the LLM will be there. There may be possible that we will be providing our own database and connect to our network to the agent. So that thing is a little bit not very clear to me.
Okay, so whatever the secure layers, whatever I am mentioning is for your agent to work, you need to send the input. Okay, and that input is where you can build the secure layer so that it won't get into the I mean what is it, the prompt injection won't happen from the input. Now your question is, we have agent, we have LLM, we are connecting the database, how the security is incorporated here. There we have the system prompt. So like I said before, I am setting the context of my agent. So my agent context is set in such a way that it should not reveal or delve into the crucial details. Okay. So this connection of the agent and the tools, all those will happen in such a way that the secure info is not getting out. Let me put it in a much more simpler way. So let's say there is a sensitive info in my database, and I won't send that sensitive info to the LLM. So there in the database, I will give limited access. I will I will construct the query. So the query formulation will happen in my end, and I will check the query, and that query will be sent to LLM. By what I mean is it will be again an agentic process where I give the fields and I construct the query from my agent, but all those will be in my control. That's what I was saying.
Yeah, got it, got it. Thank you, sir.
Okay. Okay. So and of course there is good amount of security risks are there in this process. It is our responsibility to orchestrate and perform necessary security treatments in our entire pipeline so that our data is secure and the secure data is getting into the third party agents. Okay, so that's where that challenge is there. I can explain that. So coming back to the LangGraph agents, in LangGraph agents, we have the nodes and the edges. Okay, so nodes are the individual tasks and edges are the connections which connect the nodes basically. And in agent architecture, we have single agent, network, supervisor, All these are the way the LLMs are connected. So let's say we start with a single agent framework. Now I ask a question like, what is the temperature of London? And the tools I have is a search API, weather API. So what it will do, the LLM, okay, for this we will use the weather API and we'll answer the question. That is a single agent framework. Okay. Now, if you take a supervisor framework, what it does is each one is a agent in supervisor. So it kind of routes the task. Okay, let's say a question is about the weather. Let's get into a weather asking agent or weather API agent, which will give the answer. And we get that to the user. So in supervisory framework, there is no tool. So supervisory framework, what I mean is this one. This is a supervisory framework. This is an agent. Okay. And here everything is tools. Now, what is the difference? Like why we have agent over there or why we have tools over there? Why there's a concept? Because both are giving the weather, right? I asked a question, both are giving the temperature. Can you guys kind of think like what is the benefit in single agent? Any thoughts? What is the point of having tools? What is the point of having agent? I mean the supervisor architecture. The reason is that in agents, there is a latency involved. So the fundamental difference between a tool and an agent is an agent will have a LLM call. A tool need not. Let's say I mentioned a search API, I mentioned a weather API, I said a calculator, all these are tools. But there is no LLM call here. I ask a weather API, what is the temperature? It's a API call. It's not a LLM call. There is no chat GPT, or any BERT or any Gemini model is involved. So there is no LLM call with tools. So tools, no LLM call basically. Whereas in agent, you always have a LLM call. Or in other words, agent has the capability to think and answer. Whereas tools are just equipments. Hey, you want to do a calculation? Let's use a calculator. Hey, you want to do find the weather? Let's use a weather API. Hey, you want to search the internet? Let's use a search API. That's all. So it is nothing but a tool. There is no thinking. It just gives the input, gets the input, gives out. But in agent, there is a dedicated LLM call when thinking process is involved. Is that clear? And that makes a difference. If you say there is a LLM call, then there is a latency involved. Each LLM call will have a good amount of latency. By latency, what I mean is the time required to get the output to the UI. So that is why people will, or in industry people, we will diligently think. We think more strategically whether to go for a single agent architecture or a supervisory agent architecture, because in single agent architecture, the latency is less. So you will get the output as early as possible, and that is a very strict constraint for chatbots. I ask a question and if I get the response in 5 minutes, I won't use it. I want the response in milliseconds, or I want the response at least in 2 seconds. I don't want to wait for 5 minutes to get a response. So latency is a very crucial deciding factor. And that's where, even if you say give 10 tools for the LLM, that is adding latency. If you say like I give all the tools to LLM, it will answer anything if I ask to. Need not be. It will be so slow. It will go through each and every tool to find which answer, which tool to use for this answer question, and it's a time-consuming process. As simple as that. So latency is the biggest problem. And right now in industry, we are attacking it. We try to reduce the latency. We try to reduce LLM calls. We don't go for LLM call unless otherwise it's required. We go for embedding call. We convert to embeddings because that is bit time reduction is there compared to LLM call. So the agent architecture, although it may sound so popular or interesting, the problem is even if you go for a multi-agent framework, there must be a need. And you have to be very clear about the latency required. Is that clear? Okay. So the hands-on, which I am planning possibly in another half an hour, will be a complete end-to-end AI application rather than just focusing on just the AI, because now the industry requirement is changing. So if you say like I know data science or I know particularly GPTs, people won't appreciate because things are evolving, and right now a complete software engineer, a full stack engineer, end to end, from UI, from front end, from back end, from data science, all those an engineer must be able to solve it. An industry professional must be able to understand it. So right now it's going to be not just about building uh, backend or building data science model, because I myself, like let's say some 3 to 5 years before, I was just involved in the data science module development. But right now, what I am doing is I am developing the entire microservice, and also I am somehow interacting with the UI, setting it up, adding things, because the industry requirement is changed. It's not like, hey, I know this and I am well versed in this, so I will do this. Because the advent of new tools, technologies, things are evolving. So the hands-on which I am planning possibly in another half an hour will be a end-to-end hands-on, starting from full stack, front end to back end. Uh, it will be a complete chatbot. So in front end, you will be using React. In back end, you will be using Python, Fast API. So as you can see in the flow, it will be like a chat UI front end, and you have a Node.js backend, which internally uses the Python Fast API microservice. So this is how typical in industry the AI applications. I'm showing the entire AI application, how it will be built and what are the typical tools we are using. So we finally, if you see here, in the back end, we have the trained model. Right now, there is no trained model. It's always OpenAI or Gemini. So you put the model, and then you, instead of model registry, it is right now prompt. You version the prompt versioning. So there is no model tracking. So I develop a model, I train a model, the data changes, I retrain again, and then I put another version. That is a old concept. Right now you have a API. I design a prompt, start with the accuracy. After some time, I redesign the prompt. I again calculate the accuracy. So right now it is not model version, it's prompt version. But again, it's going to be a fast API. Finally, all those models, everything, I just develop an endpoint. I expose it to the front end, and the front end guy hits the endpoint, gets the output, he goes. And for that endpoint, we Dockerize it in the container, and that's how things work. So the end-to-end flow is, you have some Streamlit or React or some custom UI which collects a user prompt, which is a user input, and you call the fast API, you invoke LLM, which again internally the fast API invokes LLM, and finally you get the answer. and the backend process and sends the results to you. Now, so myself as a backend engineer, right now we are more focused on using fast API for AI. So this fast API framework is the most popular one. If you are, let's say, you are going for industry or any IT sector or any AI company, they are mostly interested in whether will you be have a knowledge of Python, specifically fast API based microservice development. Because fast API is more designed and easy to use. You have Pydantic based models where you can define the data models, can easily handle async requests. All those are easy to handle in the fast API microservice. Okay. And here we have this concept of MCP, Model Context Protocol. So as we asked, right, there is something called, we have n number of sources, databases, we have APIs, and we have our LLM. We link everything with the LLM. But is there a standard way to connect this? A universal way. And MCP is that universal protocol. Okay. So this is the universal way to connect your data, your metadata, or your resources with LLMs. It defines how the information is exchanged. So it's not why this is required. Like, hey, I have the LLM, I have my own data. Let me design my own protocol. No, why I should follow a standard protocol? You're absolutely right. You can define your own protocol and you can use the LLM. But LLMs are third-party APIs. You have OpenAI, Claude, Gemini, Llama, all those are providing APIs. Now, if you have your own protocol, every time you need to change it. Let's say there is some change in the Claude model, in the API. There is some change in the way OpenAI consumes data. So this connections, right? It's not standard. It's something you have custom defined. Unless otherwise you have your own LLM and you have your own things to use it, it's okay. But since you are going for a third-party APIs, this MCP is the norm of it. So MCP is kind of the universal remote kind of thing, where you can use this remote to connect to a Claude model as well as a OpenAI model. So you need not change anything in the protocol. Hey, I have my database, I have my prompt, I have everything ready in MCP. I just switch the model. Instead of Claude, I will use Gemini. Instead of Gemini, I use OpenAI. So things are much more easy. This is the industry standard, right? This is the industry standard. Okay. So here we how it works is, again, it is a pure fast API call. Okay, I define MCP. It's something new. No, nothing new. Internally, we are using a fast API. So before MCP comes in, what people do? Okay, this is my database. Let's extract the schema and let's send that to the prompt. Let's embed it in the prompt. Let's send it to LLM. Now, all these are done in a fast API call, which is custom. Like everyone have their own way to do it. But MCP put that as a standard. It's a standard way where it internally uses fast API, but it kind of normalizes the connections so that you have a universal. Is that clear? Any questions so far?
Think, nobody raised their hand.
Okay. So this MCP is the backend framework, and in front-end framework, as I mentioned before, we commonly use React. So React is something like, it's highly scalable. See, the biggest thing in React is you need not rebuild everything in UI if you want to change a single component. Let's say you're building your UI for your chatbot, and I just want to change the send button. I want a text or I want to remove the text. You need not really entirely rebuild the UI. You can just change the component. It uses this virtual document object model. So this DOM is the a word, or the DOM is the thing which is used where you need not create or you need not recreate the entire thing again. Rather, you can just build the component. That just single component. And that is a very promising thing from an industrial aspect, because we don't want to waste our energy in entirely, see, building. What I mean is like deploying or starting from scratch for just a single change. That is not admissible from industry standpoint. Rather, it is always great have a component by component execution, and that's what is happening in the React. And that's why we commonly use React for our front end. So before getting into the hands-on, I will also give another technical session on the RAG framework. Give me a second. So far what we have seen is we have started with what is AI, what is Gen AI, and then specifically prompt engineering, and then AI agents, and how to develop what are the frameworks used for developing a end-to-end AI agent. That's how the entire flow is. So in this flow, there is a very crucial concept of called as a RAG. Okay, I hope everyone or most of them would have heard of this term called retrieval augmented generation. Let's get into what it is. See, in RAG there are three terms. One is a retrieve, augment, generate, as the name defines. So retrieve is nothing but I ask a question and I need some information to answer the question, or someone, let's say I ask a question to the chatbot. In the very first release of ChatGPT, it was not able to answer the current information. Let's say who is the Prime Minister of India, or who is the Chief Minister of Tamil Nadu. The current up-to-date information it was not able to answer, because of course it's a pre-trained model. It has its own knowledge cutoff date. So it wasn't able to answer. That is a very obvious thing. But what if it has some access to some external sources? Or what if it has access to the internet? What if it retrieves the relevant information from internet and augment it with the question so that it can generate the answer? That's what is happening in fact. So you retrieve the info, you augment it with the question, and then you send it to get the response. Is that clear? So this is what the very naive RAG. So as I mentioned before, in naive RAG, what happens is you have the LLM, you have the external knowledge sources. Okay, so you have the pre-trained model. Your LLM still exists. It's not like your LLM doesn't exist. Your LLM still exists, but you have external knowledge sources which information is not there in the LLM. Okay, now you have this RAG which kinds of connect this. Okay, I ask a question, and then you have the external knowledge source which has the answer for that question, but not the exact way, like the way I want, but it has the context to answer the question. Now you take both, send to LLM, it gives answer. That's all. Why this is required? Of course, the one thing is the knowledge cutoff. So your LLMs are trained up to certain date of knowledge. So what is the danger behind this is half knowledge is always dangerous. What I mean is it knows information till this date, but it has a capability to think, which means that it can hallucinate some information and it can act as if those are factual. So that is a very serious concern. Giving information or providing information or giving answers which is inaccurate or hallucinated, but still considering or sending it in a very confident way, that is very, very risky. And to address this info, we need RAG. So RAG, what it does is it updates the LLM knowledge. It addresses hallucinations. It keeps the responses up to date. So that is the very need of RAG actually. Okay. And what is the problem with the LLMs? Why we go for RAG? Of course, the training data. It's a model, right? Finally, it is a model. If you ask me like 10 years before, I was training a neural network architect, which is a pre-trained a weight file will be there along with a network design. Right now, it is a transformer architecture. So the architecture changes, but finally, it's a model. I have a data, I have a model, and I train it, and I give you the API which is exposed to that model, and you get the answer. That's all. This concept is always there. So the problem with these static models is that, of course, their knowledge, which I have mentioned so many times. And another thing is, if you want to update your LLM, it is not so easy. It is resource intensive. Let's say I have my LLM, which is trained till October or which is trained till last October or something. It's not easy to train every time or every day or up to, it's not difficult to keep your LLM up to date. Rather, what is up to date information you can supplement to LLM, like what is happening in RAG, you will get the answer. Is that clear? So how the RAG works here? So I am as a user, I am asking a question like, let's say, how many students are there in NIT Trichy? Okay, if I ask this question. So this vector DB is the crucial component. Okay. So what it does is, here I am storing all the information required in a vector database. So vector database is nothing but we are storing in vectors. Vectors are nothing but array of numbers. Okay. Why we are storing it in numbers? I hope everyone is aware of the concept of cosine similarity. Or the dot product. So we have A vector dot B vector equal to mod A vector mod B vector cos theta. So what is cos theta? It is mod A by mod B. So this A vector is your query. This is your query vector. And this B vector is the something you are finding right now. That is from your vector database. And cos theta, what it is? It is something between 0 to 1. And I say like find the vectors whose cosine similarity is 0.95. So what it does, I have A vector, I know 0.95, I need to find the B vector. So it will find this B vector, which is the context vector. Is that clear? So let me write it once again. So you have A vector dot B vector is mod A mod B cos theta, right? So this is the query vector. This is the context vector. And we find the context vector from the vector keeper. Now, one obvious question you may ask, hey, uh, this is too compute intensive. Doing a dot product will take so much time. Yes, that is the biggest problem in vector DB, and that's where we have this indexing mechanism. I don't store my entire 1540 dimensional vector, or I think it is 768 in OpenAI, 768 dimensional vector. Instead, I convert this vector via some indexing mechanism. I kind of compress and store it. That is called as index. Okay. So what is the biggest advantage is you will not take so much time to compute the dot product. So it is not that much compute intensive. Is that clear? So this indexing mechanism, and it mostly uses the centroidal. So what it does is, like, you have the vector, you take, let's say, first 100 numbers, you compute the centroid, you have one number. Next 100, you compute the centroid, you get another number. In that way, you kind of compress the vectors. Okay. So in this way, you do the indexing and you compute the vectors and you store it. And any question user asks, you follow the same indexing mechanism and finally do the vector search, get the output. So this is a much more uh, detailed way to explain. So I have the raw data source. I extract what I need to embed. So we have the raw data sources, and I extract the information. I chunk it, I embed it, I store it in the D. So this is the ABCD data preparation process, and this is called as indexing. In industry, we term it as indexing. This is the retrieval process. I mean the RAG, the entire RAG. So there is in if you say, hey, I'm working on RAG, there are two steps: indexing and RAG. I mean the retrieval and generation. Three steps basically. So if we go to the, yeah, this is much more clear. So as you can see, there is an indexing pipeline, there is a retrieval pipeline, there's a generator pipeline. So as I mentioned, there are three steps in RAG. Okay. So the color dictates what is this step. So this is the indexing pipeline. And you have retriever pipeline. And you have generator pipeline. And this vector DB is nothing but storage. It does not involve any pipeline. It's a part of a pipeline. So this is called as indexing. This is called as retriever, and this is called as generator, as you can see. And as we can see in the pipeline, user sends a query, retriever fetches the relevant doc, re-rank and filter, and LLM generate answer. All those are in a step. This is called, everything is happening in the which step? Retriever and generator. Your indexing is done. Indexing is an offline process. So you have the doc, you index and store it in the DB. RAG is working in this retriever and generator pipeline. Okay. Now, the core components here is you have an embedding model actually. Okay. So this embedding model is the one which converts the text into vector, which determines the accuracy. And you have a retriever. If your retriever sucks in finding the most relevant documents, then again your RAG will fail. So you have a retriever, you have a re-ranker. This re-ranker, it kind of resorts your filtered document. So the three components, I mean the four modules in RAG is embedding model, retriever, re-ranker, and of course LM, language. And again, RAG, it was a so common thing, like where you have a data source which is not there in LLM, or your LLM is not, I mean, it's again a pre-trained model where you have not have access to these data sources. RAG is the first sort of kind solution. And again, RAG was also evolving. So of course, right, you have the ChatGPT, then you have prompt engineering, and right now you have agents. Similar way, in RAG, it's a conventional naive RAG, and right now agentic RAG, and of course a modular RAG. So here you can see here. Yeah, you have the user query. If you take the naive RAG, you have the user query document which is indexed, and you retrieve, and finally you have the prompt with the LLM which have the retrieved context. You get the output.
Are unable to see the content.
Uh, it's in sharing mode, right? Oh, just a second. Wait, right? You retrieve the relevant context. So this prompt will have the query plus context, which is sent to the LLM, and you get the output. Now, can you see what is happening in the advanced RAG? You have a pre-retrieval, you have a post-retrieval. If you see, notice the difference. If you notice the difference, this pre-retrieval and post-retrieval is the only thing, and that is making a bigger difference in terms of accuracy. What is happening is in pre-retrieval, you are enhancing your query. In post-retrieval, you are enhancing the context. Enhancing in the sense you are making it better. Okay. And so finally you get the output. Now here in modular RAG, what happens is you have naive RAG, you have advanced RAG, but here it is kind of modular. Modular in the sense each one is a module, which is a retrieve module. You have a re-ranking module, you have a search module, you have a routing module. So everything is kind of independent. And what is the advantage here? The advantage here is it by itself acts. So what I mean is, I ask a question, retrieval module, it may go to a routing module, it may go to a search module, it will fetch the details, and then it will send that to finally to generate the answer. So here the modular RAG is nothing but conceptually you have independent modules. That's all. Now, starting from the naive RAG architecture, it started with a simple retrieval and then the generation, and slowly we go get into the advanced RAG where you have incorporated re-ranking, hybrid search, all those things. And finally, we have the modular RAG where you have each component which is customized. You can swap it, you can reuse it, you can use it independently, kind of modular rack systems. And then we have this graph enhanced. Like here, I mentioned like we have a vector DB. What if you have a graph DB? Graph DB in the sense you have knowledge graphs. So what it happens in knowledge graph is it is commonly used in recommended systems like a job ID. It is connected to which location, what department. So I can easily imagine a graph out of it. So this graph DB is so commonly used because everything cannot be stored as numbers. There is a graphical relation. A graphical relation cannot be stored in numbers. You have node, you have entity, you have connections, but it can't be converted to numbers. That's where we have the graph DB in picture. So here in graph DB, we also use RAG on top of graph DBs. So what happens is, hope the screen is visible. You have relational DB, you have vector DB. So what you do is query, I convert to a graph language query, and it is basically cipher language query. And I hit the DB, I get the response, I give that to the LLM to get the answer. So this query construction will dictate what type of DB we are using. If it is a common vector DB, just convert to embedding, do a similarity search. If it is a graph DB, just convert to cipher language and do the search. If it is a relation DB, convert to SQL language, do the search. That's all. And routing, all those, like you can see how things are connected here. So this is a very detailed flow of how RAG works for each and every component. You have a chunk optimization where you kind of optimize you split the text and store it. So that is part of the indexing. So you have in indexing, you have chunk optimization, hierarchical indexing, and in generation, you retrieve using a RAG, and you have routing, like routing in the sense which DB to select. I ask a question and I don't know whether to go for a relational DB or a graph DB to answer. And that is decided by a LLM. LLM will decide which DB to query for what. And finally, you get the relevant thing, you send it to the LLM and you get the answer. Is that clear? Any questions? And of course, in RAG, it's not again restricted to text. You have image, you have audio. There is a concept of multimodal RAG where you use unified embeddings, which kind of encapsulates all these modalities, and you get the answer.
Yeah, one question, sir. Hello.
Yeah. Can you hear me?
Yeah. Yes, sir. So, when we are doing RAG, do we need to provide the database the connectivity to internet, or in the RAG we are providing the connectivity for the current documentation with our organization or department database? From where it is fetching the current information? Is it from the internet or is it from the departmental database which we are connecting as a vector database?
For RAG, you need to connect to the database. Okay. And you can also use a search API tool if you require, but it is up to you. So this database, you can imagine kind of a tool. Okay. I
Okay.
have a database. I am so that will come under the context generation mechanism. How you generate the context for your query, whether you are using a internet or whether you are using your database, it's up to you.
Okay. Both is possible, right?
Both is possible. A
So,
database, but you have very granular control in database.
mhm.
You have the cosine similarity metric. You are constructing the SQL query. Like you can see here, I am constructing the query to hit my DB to get the information. So what is retrieved for my question? I have a very good control. But if you go for a internet, so again you need to do some kind of text post processing, context post processing to kind of filter out and get ready with the context. So a database or internet is fine, but RAG mostly we go for vector DBs or graphics.
So, sir, as you said initially that when a ChatGPT or any other model initially built, they were trained on certain days or certain data, and after that they were not able to give information about the current system. But when right now we are asking any current information from the ChatGPT or Gemini or Copilot, it is fetching the information from the internet and providing us the uh, exactly current information. So what mechanism they are using in the backend? Is it RAG or it is something else?
It is RAG. So as I mentioned, they are using search API.
Search API.
So you ask a question, okay, now it hits the API to get the relevant context, and that is supplied as an input to the LLM, and you get the response.
Okay. And when we are doing RAG, suppose we are providing our own database, our organization or departmental database to as a vector database for the RAG. And if we there is another term of doing the taking a large language model and fine tuning with our own company database or company's documentations. So in this particular scenario, what is the difference between both of these, the
Latency,
RAG and the fine tuning?
latency. Hello,
Latency. Okay.
latency. Because in RAG, as I mentioned, there are two steps. You ask a query, it retrieve the information, then you are hitting to generate the answer, right? You have a retrieval and generation. And in the case of fine tuning with LLM, there is no retrieval. You ask a question, directly it gives the answer. So the latency is minimal with the fine tuning. Whereas with the RAG, you won't achieve that latency, what is given by a fine tuned LLM.
So, in what scenario which needs to be done? Both are, I think, in use. So, what are the pros and cons of both using in this scenario? If we have to suppose I am having my own database of some legal document or any particular kind of document, and I want to retrieve information again and again. My users want to do that. So, in those scenario, when can we use RAG and when can we use fine tuning?
Okay. So the scenario totally comes under how long you want. I mean, how much time you have to develop your system. Okay. So RAG is something you can implement within 3 5 days, 3 to 5 days. But
Okay.
if you go for fine tuning with LLM, it requires good amount of resource and time, the compute resource. You need to prepare your data for fine tuning the LLMs. Okay.
Okay. GPU
And
also it will be required.
yes, of course. That depends on the how much quantum of data you have, the quantity of data. Let's say you are training with 1 lakh data points. Of course, you require GPU. Sometimes people train with 300 to 1000 data points just for the sake of identifying the category, some minor things. So in that case, you can go with some 300 data points as well. So this has the compromise with the resource and time. Whereas in the case of RAG, like I mentioned before, the jailbreaking mechanisms, all those secure mechanisms, if you put in the pipeline, you can go for your product within, I would say, like hardly 2 weeks. Let's say you have all the resources, Melvis, Vector DB, all those things are intact. Of course, indexing will take time, but it won't take that much time, unlike fine tuning the LLMs.
Okay. So RAG is more popular than fine tuning. We can say
Yes,
like that.
yes.
Okay. Yeah. Thank you, sir.
Because RAG, right? Let's say user want to upload their own document and do query on top of that. You have that leverage also. Whereas in fine-tuned LLMs, it is for your doc, you have your own LLM for your own dedicated usage. So that there is some amount of generalization in RAG as well as the faster implementation is also. That is our advantage. You can see here, I am constructing the user prompt. I'm constructing the entire prompt. The system prompt is you are a web page question answering system, and you have the web page content, respond properly. So this is the question is what is this is the user question. You can put any question of yours. Okay. And then you have the final prompt, which is the system prompt, user prompt, question, and finally you get the LLM response. Is that clear? So this is a very basic prompt engineering based workflow. Now, see, this is the now given this pipeline, I am giving my URL. There is a beautiful soup package I'm using. I'm getting the input text, the user prompt, all those I'm just doing it. But I am getting this error. Can anyone let me know what is this error? What it says? Any answer from the participants? What this error says? So this error basically says you are giving the context and the question, but it is more than the number of tokens that the model can consume. See, I am giving the input length of 38,000, but the maximum length is 4,000 only. That is why I am getting this error. So what can we do?
Either we have to reduce the input length or increase the max length.
Okay. So obviously we can try with reducing the max length. I mean, reducing the input length. But if you want to increase the max length, I think like you can maximum consume to 4,000 tokens only, right? So you need to change the model, right?
Yes, sir.
But can you use a bigger model in a simple Colab notebook? Can you instantiate here? No, right? Because it is resource compute intensive. I'm using a simple Colab notebook to do my demo. I can't afford a very big model which I can use it in my Colab notebook. So as you mentioned, we need to go for yeah. As I mentioned, we need to go for reducing the input length. How can we reduce? I can't ask my user to say, hey, give the user question within this token length because I can't afford a bigger token length. No, that can't be done. So the obvious way is to reduce the context. I can't for every question I can't send my entire web page because that's what is happening, right? I take the web page URL, I use beautiful soup to extract the text, and then I'm sending the entire web page content for the question, which is not at all a scalable design. And considering a very small model that you're using, let's say you're using GPT-4o or Gemini, which has 1 million token context limit, yes, obviously you can afford for that. But if you're using a very simple token model, which has 4,000 tokens only as the token limit, definitely that is not affordable. So that's where we go for the rack payment. So this one is a simple rack approach. You can go through the code. So here I'm using this sentence transformer all MPNet base V2 model to get the embedding. And you have the vector DB where you convert the embeddings and you store it in the DB. And then I'm instantiating the retriever. And finally, I'm using this LangChain framework to retrieve the content. Okay. Now, if I ask the same big query, the same big web page, Captain America Wikipedia page, it is able to answer. See, you are getting the answer. So the base of this hands-on is prompt engineering. You can see what is the problem. You can't use prompt engineering every time, especially if you are going for a small model, if you have a limited context size, if you have a cost constraint, resource constraint. And RAG, as you can see, it can easily solve your problem by just taking the relevant context for your question. And you, as you know, like you have Gemini embedded in the Colab notebook itself. So you can try uh, any questions with Gemini on the fly in the Colab notebook itself, like any questions, any doubts, because nowadays we have a concept of vibe coding. So what I mean by vibe coding is how efficiently you are using AI to code. It's not like we as humans, we need to sit and code and we need to see how it works. It's now the thing of how better we connect the systems and build the product. So I encourage everyone to use Gemini, which you can find it in the Colab notebook. You can run the notebook. You can ask any doubts in Gemini itself. You can try to use AI to see how things are working. And also, I encourage you to go through this. Yeah, let me go through the second hands-on also, how it works. I would like to go through, I think I opened it here. So this is using LangGraph. I think everyone can see the screen. I will also share this link in WhatsApp to ma'am. Ma'am can share the notebook and the GitHub link. So this is using LangGraph, Fast API, Gemini, and React end-to-end complete chatbot. Okay. So what is I can so you have everything, the details of how to run it, what all the prerequisites, all those things are defined in the README. You can go through and try it. Okay. So you need a Gemini API key for running this. So, but for a Gemini API key, I think everyone has a Google account. So you can get your own API key and you can put it. So this is for instantiating the backend server. So as you know, like we have backend and frontend. The backend is the Fast API server. You instantiate your backend server. And then for frontend, we are using React. So for those who are new to React, you can just consider that as a UI. Don't think more about what is React or how it works, because it is you can get into the details, but basically here how it works is you are linking the endpoint. I will give a walkthrough of the code, but for starters, just consume like you have a front end code where you are linking the endpoints. That's all. Okay. So this is the code to run the React. Okay. Or you can run from the folder like this as well, whichever is fine to you. And after you do that, you can just install the dependencies and you can start the front end. So once you go with the start the front end, you can you can see your complete app in this posted in this local. Okay. Now I will give an overview of the backend and front end code completely. After that, you can start it and see how it works. So this is the main function. Like here, this is how I hope the screen is visible. This is the main function where the entire code starts. You have the agent router, which is the business functions are the put up in this endpoint. Now this is pointing to the agent code, so which is this code, router's agent. Here you can see two endpoints. So this main code, I give a topic. It can either generate a essay or generate a poem. A very simple task. Okay. But how you can, what you can see, what is happening here is, I am building a graph, but that is just with one node. It can be a simple agent. I mean, it can be a simple LLM call as well, which is what is happening. But you can build more nodes. I will give another example how it is happening. But right now you can see, I will go to the LangGraph agent. Yeah. So if we go to the generate essay, generate poem, which is see, this is the LangGraph agent. Here you can find the actual task, that is the generate poem, generate essay code. This is the agent code. This dict is the state of the agent, which is of dict format. And then I'm adding a node, which is for generating essay. This is for generating poem. And finally, I'm compiling the graph. Is it clear so far? Now you can ask me, what is the role of agent here? Here nothing is there, right? I'm just generating essay, generating poem. Yes, it is an independent nodes here. Now I will show you another code. Here you can find a proper agent. Can someone say what is happening here? I will give you 2 minutes. Just go through these lines. I hope these lines are visible. I think this is straightforward as well. Can you explain what is happening here? Just go through these lines and let me know, like, what can you think of here? Hello. So you can see here, right? There is a router node, there is a calculate node, query node. So if you think like, I am asking a question 2 plus 3. This is a calculation. There is no reasoning involved. So it should go to calculate node. If I ask what is AI or just AI, it is a reasoning question. It should go to query node. That's what is happening here. So the router node, it checks whether the input is a text or a mathematical calculation. Okay. And based on that, it says the route, whether it needs to go for calculate or query. And based on calculate or query, it basically goes to the conditional edges. Okay, so like calculate or query. Now calculate decision, the node is calculate node. Now if I go to the calculate node, this is what is the thing. It will calculate and it will give me the result. Now for query node, what will happen? It will go to the LLM call, right? So where is query node? Here I define. You are a helpful accident, answer this question. So this is an LLM call to answer your query. And there it is a simple mathematical calculation. And this is the agent. This is what we define as an agent. An agent, and you have tools. What are the tools you have? You have calculator, you have LLM, Gemini. So based on your question, it either use calculator or tool, which is decided by the agent. It is a single agent framework. Remember, I have taught you single agent, where a agent is supplied with n tools, and based on the query, it will take the tool and use it. And based on query, how it takes, that is decided by this router node. The router node decides which tool to take. Is it clear? So now to run this code, you can go through the readme.md. You can just follow these instructions, just install the requirements and get your Gemini API key. For getting the Gemini API key, please go to, you can just Google AI Studio Google. You will get into the AI Studio website. Just register with your Google account and get the API key. And then just start the server. You can run the backend, then run the front end. So for front end, right, how it works in front end, let me explain that also. See, front end, you have this app.js. This is the guy. So here you are linking your backend endpoints. Where we are linking it? So I'm asking in the UI, enter the query or math expression. After getting the input, I say I click set input, or I click the button. After that, it should take the text and it should supply to the endpoint, right? Where it is happening. It's happening here. As you can see, you have agentic chat, which is the endpoint name, and I am supplying the input, which is the input text from the user. And finally, we get the response. So React, you can think of like you are somehow connecting the endpoint with the UI code. Say this div, all those, like you can, all those are the basic CSS setups. I'm creating a form, I'm putting the style, font family, all those. These are some UI setups. The main concern here is how you are linking the endpoint with the UI input. That is the thing, and that is happening here. Okay, this is the endpoint. And here you have the input, and here you have the output. So is it clear? I think I shared the notebook with ma'am. I will also share the GitHub links, the presentation. Ma'am, can you share the presentation? It will have all the GitHub links for them to start with. I will share the document.
Hello, sir.
Yes, ma'am.
Like it ideal. Like...
Sorry.
No, sir. It's go ahead, sir.
Yeah, I have shared the notebook, Python notebook. Can you please share to the team? Meanwhile, I am sharing the GitHub repository. Hello, can you hear me?
Yes, sir. Your words is audible.
Yeah. I am sharing. I have shared the GitHub repo. Can you please share? I mean, I have shared the Python notebook. Can you please share to the team, the participants?
Sir, where we shared, sir?
I shared in the WhatsApp group. I mean,
Okay.
to you in WhatsApp. Sorry. I have shared you the presentation as well, which will have the Python GitHub links. I think participants can try both the Python notebook and the GitHub. They can go through and start. So for getting the Gemini API key, I suggest everyone to use this link. I am sharing in the chat itself.
Yes, sir. Both the code and the PPT shared to the participants.
Okay. I have shared in the WebEx chat the AI Studio link. I mean the Google AI Studio. You can use that to get the Gemini API key. If you guys don't have, you can use your personal Gmail account. You can get the API key to run the GitHub repo.
Excuse me, where it is there?
Sorry.
Sorry, where it is there? WhatsApp group or email?
Ma'am, can you please answer? I mean, they are asking where it is there.
Is it on email or WhatsApp group?
It is in WhatsApp group.
Okay, ma'am, could you please add me in a WhatsApp group, please?
Ma'am, I am also not part of WhatsApp group. I have not received anything.
So
Chandrasekhar
can
this
you
side.
share your phone number in the chat?
Sure, sure. Thank you so much.
You can add it.
start with the Python notebook. Please run through cells and see like can you see the difference between the prompt engineering and that. This will take some time to run because you are installing all the packages at the first time. Also, I would request you to go through this diagram before the code. It's not about, it's about understanding the code rather than running it and see like how it works. Please go through the different components here and ask any questions. Also, this is a Gemini demo. You can try this also. I have the GitHub link included in the presentation. This is a basic chatbot. This is an agentic. So I suggest you to go through the code, run it, understand it, and you can ask me any questions. So in the hands-on, we have covered the prompt engineering versus RAG using web page Q&A, and then we used React and Gemini API to build a agent. So this is for the RAG and prompt engineering web page Q&A. This is the land graph based solution. Please try both of them. Any doubts? You're able to run the may take some time. are able to run the Python notebook.
Yes, sir.